The next gate is the NAND gate. So the NAND gate can be represented by an AND gate followed by a NOT gate. This is the A input, B input, and here is the output. So when it is 0 and 0 AND gate, here will be 0, NOT, it becomes 1. So the output here will be 1. Next, when it is 0, 1, so here 0, 1, 0, 1 is still 0, NOT becomes 1, so this will still be 1. Next, 1, 0, so when it's 1 here, 0 here, 1, 0 AND gate here will be 0 and output will still be 1 because of NOT, still be 1, and here will be 1. And lastly, 1, 1, 1, 1 AND gate will be 1, and NOT there, NOT of it will be 0, so the output will be a 0. This is the symbol for the NAND gate. So it comprises of an AND gate followed by the NOT gate. The circle here represents the NOT gate. So A, B, A input, B input, and Y output. So using Boolean algebra, this will be A and B, a line on top to represent the NOT gate. Summary, its output is 0 when both inputs are 1. So notice here, when both are 1s, then the output is 0. Next, the NOR gate. This is an example of two gates acting as a NOR gate, that is OR gate followed by the NOT gate. Let's see the result when both are 0. So if 0, 0 is OR, it means it is 0 and NOT of that will be 1. So this will be a 1. Next, 0, 1, 0, 1, 0 and 1, OR of that will be 1, NOT of that will be 0, so this will be a 0, followed by 1, 0, 1, 0, OR of that is 1, and NOT of that becomes 0, so here will be a 0, and lastly 1, 1 will be a 1, NOT of that will be 0. So this will be 0. This is the symbol for the NOR gate. It's a combination of the OR gate followed by the small circle here representing the NOT gate. The Boolean algebra for that is A plus B representing the OR gate and the line on top representing the NOT gate. Summary, output is 1 when both inputs are 0. So when both inputs are 0, then the output will be 1. Next, combination of logic gates. The figure below shows a circuit consisting of 3 different logic gates. Complete the truth table for the system shown above. So this is the A input, B input, and Y is the output. First, try to recognize the various gates. This is the NOT gate, this is the AND gate, both of them are AND gates, and this is the OR gate. Now try to fill in the truth table. So the first one will be 0 and 0. So 0, there's a NOT here, so becomes 1, and 0, this 0 goes down, here also will be 0. 0 comes over here, becomes 1, going through the NOT, and the 0 goes up, so here will be 0. So 1 and 0 will be 0 under the AND gate, 1, 0 also 0, 0 and 0 OR gate will be 0. So the first one is 0. Next, 0, 1, so we put here 0, 1. So 0 bring over, going through the NOT gate will be 1, and 0 goes down here, so this also will be 0. Here 1, NOT will be 0, and the 1 brings up, here will be 1. So 1 and 1 is 1 because the AND gate. 0 and 0, 0. So 1 and 0 is 1 under the OR gate, so this is 1. Next is 1, 0, so write down 1, 0, 1, NOT here will be 0, 1 bring down here, and here 0 bring over will be 1, and 0 coming up here, so this will be 0. So 0 and 0 here will be 0, 1 and 1 is 1, 0 and 1 is 1, so this is 1. Lastly, 1, 1, 1 not becomes 0, 1 bring down, here will be 1, 1 not will be 0, and 1 coming down up here will be 1. So 1, 0 and 1 will be 0, 0 and 1 will be 0, so 0 and 0 will be 0. So this is the truth table for this logic gates. Question: the diagram shows a combination of logic gates circuit with input signals A and B. Draw the output signal. First, recognize what are the gates. This is the NAND gate, NOT gate, and this is also the NAND gate. Next, write down what is represented by the signal. So this is a 1, so this is a 0. Here high level means 1, here another level 1, and this is a 0. Down here it is 0, 1, 0, 1. So follow the signal as it comes to A and B. So the first one is 0, 0 from here. So 0 and 0, 0 and 0 under the NAND gate is 1. 0 pass over here becomes 1 because of the NOT gate. So 1 and 1 under NAND will be 0. Next, 1, 1. 1, 1 under NAND gate it will be 0. 1 under NOT gate becomes 0. So 0 and 0 becomes 1. Next will be 1, 0. 1, 0. 1, 0 under NAND gate will be 1. And under NOT gate it becomes 1. So 1, 1 becomes 0. Then finally 0, 1. 0, 1 under the NAND gate it becomes 1. 1 through the NOT gate becomes 0. So 1 and 0 through the NAND gate will be 1. So the signal output should be 1, 0, 1, 0. So this is the answer. Here is 1, 0, lower level, high level is 1, and then here 0.